So what happens is it's not just a matter of the atmosphere melting the surface of the ocean, or melting. It's a combination of the North Atlantic coming into the Arctic and the amount of fresh water coming in from the Pacific. It's a matter of the circulation of the atmosphere. It's a matter of the surface heating from the atmosphere. All of that combines. In addition, the influence of the ice itself is, the ice reflects sunlight. And when the ice decreases, the amount of sunlight that's reflected decreases. So the system itself warms because of that. So in effect, as the sea ice decreases, there's a positive feedback which accelerates the process. And so it just turns out at that point, the amount of sea ice exceeded 50%, or the first year sea ice exceeded for 50%. And that was because the area of open water exceeded 50%. So if you look at numbers, various flavors, there's different ways of interpreting it: half full, half empty, glasses, and so on. In the case of the Arctic, the common perspective has been to think of the Arctic in terms of its lateral extent, how much area the sea ice covers. However, the rate of change of sea ice is much faster in the vertical. So the ice is thinning faster than it's decreasing in the lateral extent. And it's that vertical component, it's the ice thickness, that ultimately, right now, is the more important feature of the ice system in the Arctic. And so the perspective has been the lateral extent, because that's something we see from satellites. However, the thickness turns out to be a more important driver of the change in the sea ice extent. And so that's the reason it has rapidly decreased in that. Does that answer your question?